Welcome to qnawire.
Consider a centrifuge rotating at an initial angular velocity of 3,600 revolutions per minute. The centrifuge continues to rotate for 50 revolutions before eventually coming to a stop. We are interested in determining the constant angular acceleration experienced by the centrifuge as it slows down. To begin, we'll write our rotational kinematic equation for a rigid object. We have the final angular velocity squared equals the initial angular velocity squared plus 2 times the constant angular acceleration times the difference between the final and initial angles. We can sketch the motion of our object by indicating the axis of rotation as this green dot coming out of the screen and this blue arrow indicating the direction of the motion. From this, we can see that if we allow the initial angle to be 0 radians, then the final angle is simply 50 times 2 pi. This is because each revolution is equal to 2 pi radians. Writing this out, we have 50 revolutions times 2 pi radians per 1 revolution equals 100 pi. So now we have theta f and theta I. We're going to solve for alpha, so we're not worrying about that quite yet. We know that it's coming to a stop, so the final angular velocity is 0. We're given the initial angular velocity, however, it is not in standard units, so we're going to convert that real quick. We have 3,600 revolutions per minute, and using the same conversion we used over here, 2 pi radians is equal to 1 revolution, and there are 60 seconds in 1 minute, so we'll be dividing by 60. Our units cancel, and we are left with 120 pi radians per second as our initial angular velocity. Now we can rearrange our equation so that alpha, our constant angular acceleration, is on the left side and everything else is on the right side. We have alpha equals negative omega I squared. Note that the negative sign is not included under the square, divided by 2 times the difference between the initial and final angle. And we know from over here that the initial angle is 0. Plugging in the rest of what we know, we see that we have negative times 120 pi per second squared divided by 2 times 100 pi equals negative 14,400 pi squared divided by seconds squared over 200 pi. The numerator, or because pi squared is in the numerator and there is 1 pi in the denominator, the pi in the denominator cancels, and we are left with alpha equals negative 72 pi radians per second squared. Equivalently, this is approximately negative 226 radians per second squared if we multiply out the pi and include that with it.